My name is Anna Steffi, and I am part of Group 19.
My name is Zach Barnett, and I'm part of Group 19.
I'm Alana Jadwalis, also Group 19.
I'm Zolan Jia in Group 19.
This is our video for Lab 11. And so we are tasked with designing an experiment to test the axis momentum principle or something. And so our first discussion question has to deal with constructing a scientific argument that convinces everybody about how to find the moment of inertia using the IOLAB about an axis that is not crossing through its center of mass. Does anyone want to go first? I guess I can talk about mine. I have the claim, evidence, and reasoning stuff. I thought that whenever I fixed a rigid axis about the IOLAB, I'm still going to have it circulating on the y-axis, but I'm just going to take into account the fact that the axis and the force are going to be obviously separated. And so I'm going to use like the parallel axis theorem to be able to account for this. And also the rod is going to add mass, especially since I use like a really heavy chopstick. And I thought that from the IOLAB, we'll be able to identify alpha and angular acceleration because it just gives us that. And then we can find the force acting on the system by weighing it using the IOLAB, turning on the force and acceleration using F equals mass times acceleration. And the tension force by the string acts through a reference point, and therefore calculations are necessary. However, the force by gravity acts through the center of mass, which we can calculate because we have been given our mass with the IOLAB. And we understand that torque is such, and that r is a straight line distance from the axis of rotation to the point of application by the force. We will measure that using the distance from the rod to the center of the IOLAB. This is just kind of like my choice. It's like a personal assumption I'm going to make that I can like kind of guess where the center of mass is on the IOLAB. And because we now know that torque is the moment of inertia multiplied the angular acceleration, we can set these two equations equal to each other and then solve for inertia. And that was my part for the experiment. And I don't know if anybody has any thoughts on that.
I do have a question for that because you just mentioned that you use like heavy chopstick, and like I'm using something that is even heavier. Should I take account, of the mass of the stick, or should I just use the mass of the cart?
I think I personally use both. I think you could theoretically just argue that like it is still negligible. I used the force sensor and weighed my whole system together and used that mass for the total mass.
Okay.
Yeah. But if you didn't do that, you could still like just argue that or say that that was an issue, but now that you know it should be, you know why you're wrong, so it's fine.
Okay.
Did anyone else do anything like really different than what I explained?
Yeah, I can't necessarily speak for its validity, but I did something slightly different in that I kind of did like a normal pendulum setup, but I did it horizontally. Would normally be a hanging down vertically. I did kind of strapped. It's hard to describe without pictures. I'll upload them later. But I had it kind of set up long ways, and did a pendulum pulling the side towards me and letting it go like that. And then so it's still rotating around the y-axis kind of thing, just on a different axis than like, you know what I mean?
Yeah, I saw your pictures in our group chat and it looked really interesting. As long as your data looks good, I mean, I don't
Yeah.
think anything would be different.
Yeah, I mean, it looked like a pendulum. So I mean, I feel like it accomplished the goal, but it just went a different way about doing it.
I think that should be fine.
I had,
Oh, go on.
yeah, I did something similar to yours, but for I think it's part A or like part for like one of the questions, I wasn't sure what point on the graph to use. So I think that might have messed up some of my calculations, but I did use like parallel axis theory, or yeah, the parallel axis, and I did that for my calculations. But yeah, I wasn't sure what to use on like the first graph for the angular acceleration
Oh,
yeah, like
this?
there. Yeah, I wasn't sure what point to use.
Yeah, I think I just took a mean because here, oh, that's really interesting because this is canceling out. And that's why this is 0, because you can use like delta t under delta, I forgot what this Greek symbol is called, to find your angular acceleration, or it's just given right here. And this, they'll only give you this if you highlight a portion.
Yeah, when I did I then like chose to only like highlight part of it, so like the values wouldn't cancel out, but I wasn't sure.
Yeah, I think mine just looks a little different. Mine still looks wavy. I think I just rotated, I made sure it just rotated as like slowly as possible for me,
Oh, okay. That makes
and trying to keep it constant. And that's why my graph, I think, looks like this.
yeah, I was not sure if I did it right, so I would trust you.
Yeah, I mean, it's interesting though. I wonder like what the physics are behind this graph and how the angular momentum could be 0, even though it's spinning and stuff. But let's look. All right. So I just pasted this here because I think it belongs here. Maybe, I don't know. We have to do that again. Based on our Q3 answer, how you could find the moment of inertia of the IOLAB cart about the axis, which is not in Q3. I think we already talked about this, or at least I talked about how I got it right here. So I already covered that in Q3. How did anybody else get the moment of inertia? This is just how I'm going to calculate it, I guess. Like the calculated value. Yeah. It's just, I'm going to use parallel axiom theorem. The moment of the inertia of the system is the moment of inertia of the center of mass plus mass total multiplied the distance between the axis and the center of mass squared, where, and then it's just written out with moment of inertia. And I did that work in Q3. Did anyone think anything differently?
Not really. I wish I could give you more input, but I mean, I did pretty much the same thing you did in calculating my values. So I really didn't stray too much from what you did there.
Okay, well, that works out. And then our last discussion question, we are just talking about the differences between the calculated and the experimental. And what were your guys' values for that?
Well, my calculation is kind of messed because when I was trying to, I just post the image of my setup, so you can find that the stick is kind of too long and too thick, so that for me the length and the it's really hard to measure it. So I didn't like find out the final value because like I'm not sure if I should like assume that the length is like from the middle of the overlap to the end of the stick.
I see.
Yeah, I should post my images in the document.
Alana, was one of your how were your values different?
They were not close, so I don't think I did something right. Yeah, which one? One of them, my value for E was way smaller. Which that one was the experimental, I think. So I think I did it.
For E, it's the calculate the momentum inertia of the iLab using theoretical formulas. And mine was super, super small as well. And I noticed that in lab 10-2, or the last lab, whichever number it was. I got the same thing, actually. But despite getting a smaller value, I just kind of thought that experimentally, the moment of inertia kind of makes just more sense, being not like a ridiculously small value. Mine is like 5.13 times 10 to the negative fifth. And the iLab like is just accounting for things that I'm just assuming like really a lot. Like I'm assuming a lot in both because I'm taking measurements in both and using measurements in both. But I think in the theoretical like plane, I'm assuming just like literally everything. To whereas in the iLab, I'm getting at least some real data, and my graph didn't look poor. So I personally think that comparing the two values, I just would trust the iLab one more.
Yeah, I mean, I agree. I feel like with a value that small, it's just unlikely to be the accurate number.
All right. I think that is it. I see yours and how that might be a problem.
Yeah.
Interesting. But besides that, I think that is it. Is everyone good, or did anyone want to say anything before we?
I think we're good.
Awesome.